Yeah, I think I will, especially with the PowerPoint. As soon as you have access to your computers, go to dplyr no solution. Okay, same file as same location as usual. We're still in workshop 2. And I want you to go to chunk 2 whenever you have access and run this line here. Install packages Tidyverse. Okay, because Tidyverse is huge and it takes a while. So while I'm talking on the about the PowerPoint, yeah, if you can just install it and it will run. So last time we started talking about working directories, how to load an external data frame from a CSV file. And I think we didn't get to packages and libraries. But I want to stop it here. I put some new slides. And I was thinking I want to talk a little bit about social network analysis now, because on Wednesday, so next time, we are going to be, you are going to be working on your own data. And maybe if you want to do a data network analysis, maybe you want to start thinking about what you need from how you need to shape your own data to be able to do a network. So I put some new slides here. So these are the old ones, and this is what it's new for today. So I think most of you already know, so I'll go a bit quick, but if you have questions, just let me know. In a network, we have some nodes. In this case, I put some hospitals or healthcare facilities. It could also be people. It could also be farms. It could be anything that is like an entity, as something. Those are the nodes or vertices. Then we're going to have some edges or links, and those are the connections that are between them. So for example, here again, you have some healthcare facilities, and these are the transfers of patients from one to another. It could be we are talking about us here in the class. Another example will be you are the nodes, okay, and I mean, I'm also a node. We are the nodes. And the relationships that we have, like for example, if I go and talk with Moniz, that connection could be an edge. Then Moniz goes and talks with Sam. That connection is another edge. Okay, so the links are the things that you, get together the different nodes. Then in a network, you can have directionality or not. This one here does not have a directionality. You know, there has been a contact, but you don't know if there's an origin and a destination. So you don't know if I talk with Moniz because I approach her, or if we talk because she approached me. We don't know that. But we can add some directionality, and here, for example, we see that this facility is sending patients to this facility here, and that is depicted by the arrow. In this case, this arrow here, this facility is sending to this facility, and this facility is also sending to this one here. Okay, so we have an arrow with two heads. We can have what we call edge attributes, and these are characteristics of the edges, characteristics in our case of the transactions of people, of the transfers. For example, we can depict it in different ways, and the edge attributes can be many things. In this case, I depicted it, I made a bigger arrow if we were sending a lot of people from this facility to this facility. We can see from this facility to this facility here, the arrow is very narrow, so we didn't have that many transfers there. From this one to here, it's like mid-size, so yeah, there were a few. But it could also be another edge attributes. It could be the day or the month or the year, like some time characteristic of the transfer. Where did it happen? Did it happen in January? Did it happen in 2016? Did it happen during the weekend? So that could be another edge attribute. Can you think of a different edge attribute, like in our situation with the hospitals? And an edge attribute, again, it's a characteristic pertaining that transfer.
It's an AR patient?
Huh?
AR patient, an AR patient?
AR, like emergency?
Antimicrobial resistance.
Okay. AR, sorry. Antimicrobial resistance for the patient. Okay, so if we have, that will be, if we have data at the patient level, I think, okay? So in that case, the nodes will be patients, and the transfer, I don't see it. How can you develop a bit more?
I don't know, but I was just thinking if the nodes actually weren't patients, but
Mm-hmm.
you were like if there was an outbreak and you're trying to trace the
Mm-hmm.
transmission process
Mm-hmm.
as per a patient transfer.
Okay, so we have nodes are patients, and we have a transaction. So that's a contact between two patients, for example, or
Sure.
between two people, and we have. It could be, but let's try to look for something easier, because it could be that transaction, in that transaction, what happens, like I transmitted like an antibacterial, an AR pathogen. So that could be in that case. So you have a column, an H attribute, a variable that said in that transfer, did an AR transfer occur or not? So that could be, but give me more examples, something a bit more easy to think about. Or maybe it's not easy for me, but maybe for you it makes a lot of sense. It could be.
So do you mean, when the edge attribute, do you mean something that can be like the number of transfers?
Number of transfer. In the data set that we have right now, that could be an edge attribute if you have the transfers aggregated. For example, we had hospital A and hospital B, and we have a transaction there. So it could be, yeah, for example, the number of people, if you have those transactions, each of those transactions is recorded within 30 days, which is, I think, the way you have the data. So each of those transactions is all the transactions aggregated that happen within 30 days. So one of the edge attributes could be number of people. So number of people that were transferred in that transaction that we have recorded, that it's actually a 30-day period. So that will be the number of people that were transferred between those two hospitals within those 30 days. That could be an edge attribute. Okay, so edge attributes are the characteristics of that transfer. Okay, for example, go for it.
I was trying to think, like, what besides sort of volume or number, like, could you change about edge?
Yeah, so it depends on the situation that we're talking about. If we go back to the example of people and communicate it, I could tell her a secret, or I could tell her like the type of connection that I'm having with her. It could be a secret, I could be talking about weather, I could be talking about work. So that will be a topic of the connection that we had in that situation of people. If you are thinking of another example.
Or I'm even thinking like among transfers, like different risks, risk scores.
Different risks, for example, yeah.
Risk of developing a resistant infection or something like that, or patients with catheters.
Yeah. For example, within that transaction that we had, that we have the data in our case, like let's say per 30 days, how many of those patients had catheters that were transferred from A to B? Okay? Yeah. So those are characteristics of that transfer, characteristic of that specific edge. Okay, number of people, time, type of transfer. I don't know. This transfer could be happening, like the person was just walking from one hospital to the other, or maybe the transfer happened with an ambulance, or the transfer happened, I don't know in which other ways it could happen. So it will be characteristics of that edge, characteristics of that transfer. Okay? We'll see more examples when we work with it. We also can have node attributes. So those will be the characteristics of the facility itself. Okay? For example, here we see that this one has, maybe here I have represented the number of beds of that facility, and that's why this bubble is huge, because this hospital here has a lot of beds, and here this one here has less beds, so it's a bit smaller, and the same with the other ones. So I already gave you one, a node attribute, a characteristic of the facility could be number of beds. Which other thing could be?
I have a question. Is it one characteristic per node and edge, or can you do multiple?
So it will be, so for example, if we are talking about the characteristic for node, we have all the nodes. Each node will be a row, and each variable, each attribute, each characteristic will be a column. So for example, we have nodes A, B, C, D, facility A, B, C, D, and we have a column that says number of beds. So each facility will have a different number of beds. Does that solve your question, or?
Yeah, I guess I'm just confused if a hospital had a lot of beds and another characteristic you were interested in was if it was like a teaching hospital or not.
Mm-hmm.
How would you visually represent that?
So that will be another column. So that will be a teaching hospital, yes or not. Or what type of hospital? Teaching hospital, non-teaching hospital, residency hospital, or I don't know. It will be another column, a different column. Not all the attributes that we're talking about can be represented visually. You can, but it doesn't always make sense. For example, here it's easy when you're talking about size. It's like, okay, I'll make it bigger. It makes sense. Teaching hospital, non-teaching hospital, that will be a categorical variable. So maybe we can use colors for that. Or we can use instead of, or shapes, exactly. Instead of a circle, we could use a triangle or a square. So there are different ways that you could be representing that. Okay? So another node attribute is very similar to what you were saying. For example, it will be type of facility. Okay, so here I'm representing type of facility according to different colors. We can use also different shapes, other things, okay? So when you have a network like this, in your scenario, why is it useful for you? Why do you want to have a social network analysis of your hospital data? What do you want to know? What does it mean that this bubble here is very big because in this case is representing the number of beds? What does it mean that this hospital is sending a lot of things to a lot of people to this other hospital? If you see this hospital is receiving for many, this one, for example, is only sending. So what are the implications of that?
You want to know maybe which hospitals are the influencers, or maybe a disease spread, or
yeah, that could be one thing, disease spread. So for example, this one here that is receiving for many other hospitals, I would think that it might be at a higher risk of getting a disease from different hospitals, whereas this one here is not receiving from any hospital, so the probability that this hospital is receiving a disease from another hospital is pretty low. Okay, so that could be one of the things. What I made here like a little summary of the things that I think about. We can identify hubs, meaning important facilities regarding transfer, and this identification of hubs can have different meanings depending on what you say. For example, for me, I think it will be important how many patients it's receiving, for example, but you could be thinking of something different. That's very important for disease spread because you can implement different control strategies. If you know that a big hospital is sending to many other places, you should be implementing a lot of control strategies there. Also for disease introduction, you can do some prevention strategies. If a hospital is receiving, you want to be sure that it has prevention strategies in place. And I hope I'm using the right terminology. Yeah. Okay, so that will allow us to create targeted and cost-effective interventions, okay? You can also use this social network for regression and try to identify different risk factors. And also for outbreak investigation that Kyle was mentioning before. So an example of what we are going to be using, like data-wise, we're going to be having two different tables. One's going to be for the nodes, and it's going to look like this. Okay, so ideally, we will have a key column that is going to be a unique identifier. In this case, the example that I gave you here, I actually have two. One will be the participants' names, and the other one will be the ID column. Okay, this could be the HPD number, or it could be something, if we have a unique identifier, that will be our key. And then we're going to have all these things here are the node attributes. Okay, so these are some examples. We're going to have latitude and longitude. We're going to have a premise type or a hospital type, healthcare facility type. We're going to have scale, area, it could have different things. This example that I brought here, I think I mentioned the other day, but if I didn't, I'll say it now. It's an example about farms and pigs. Okay, so this is simulated data. It doesn't exist. The participant names are the names of fictitious farmers. We have a special ID for each of them: latitude, longitude, premise type, farm, market, or we have others. Scale, how big that farm is like it's industrial, like a big one, or backyard, small one, and where in the country are there, like in the north or in the south. So these are just some examples. For the edges, there are different ways of talking about edges, depending again how we talk about the nodes. We can measure contacts at different levels. For example, between healthcare facilities, we can get some data about this with national traceability or hospital records. And then if we are talking about people, and I think I saw at least one paper talking about contact and a social network between patients, nurses, and doctors. So they did it at the person level, and that you can do it with direct observation. You can do surveys, or you can even put some GPS tracking on people, which actually there's an example. I tried to find it, I couldn't find it, that they did an experiment in a bar. Everyone knew that it was happening, but they gave them little devices that were GPS, and they were just studying how people connect with each other within this bar, people who didn't know. And then they studied that data set, and they did some analysis with that. I couldn't find it, but yeah, there are different ways of creating networks, different levels that you can create it. We are going to be working with nodes as healthcare. Or in the dummy data frame that I gave you, the nodes are going to be the participants, the farms of the participants. So the edge data set, the second data set that you're going to have to create a network, is the edges data set. We're going to have always an origin and a destination, and these are going to be coming from the key variable that we had in the node table. Okay, so that unique identifier that you had in the node table is what would come here. Okay, so this is Brandon sent some pigs to Anissa in February, and he sent 106 pigs. Okay, I could have another one here. I mean, we could have many other edge attributes. These two are edge attributes, and you can have them or you can not have them. It's up to you. But what you need for sure is to have an origin and a destination. So you need to know where is that transfer originating and where is that transfer ending. Any questions so far? So these are the two tables we're going to have, one for nodes and another one for edges. Then when we start creating the network, this is going to be linked by the participants' names, okay? It's going to know that this one is sending to this other one, or that this one is receiving from another one. We are going to merge this. Actually, the functions that we're using for social network will merge it on its own. But sometimes maybe we want to merge the data, the information we have here, and plug it into the edges data set. For example, the latitude and longitude that we have here. We want to put it in here, and we will create one latitude and longitude for the destination and another latitude and longitude for the origin. And with that, we're going to be able to map our network. So just this morning, I actually mapped with this shapefile you sent me. I mapped the network, the CMS network that you gave me. I just have some errors because of the locations that I didn't have that I imputed with this macro. And there are 6 that are really off, so I need to deal with those. But I already have it mapped. We can make it pretty, we can make many other things, but the basic thing is there already. Okay, so and you will be able to do it really soon. So going back to the slides that I had prepared, talking about packages and libraries, R works with packages and libraries, and packages are tools, boxes of tools. Okay, so imagine that you have a toolbox, and inside you have plenty of functions. Okay, so when you are installing a package, and I don't know if did you have time to install the Tidyverse? Are your computers working?
I installed it last week.
Okay.
And now I just ran
in the library.
Okay.
And I got some warning messages,
Yeah.
but
No problem.
I
Perfect.
think it worked.
So did anyone have problems running the install package Tidyverse
I
line?
think it worked, but I don't know what to expect.
Okay,
I mean,
we'll
like,
see.
You get a lot of red messages, but you get, it looks like it
Yeah.
builded the package indices and
Mhm.
installed.
Perfect.
Under version.
So probably it worked. Yeah. So that thing that you did with the install package, if you pay attention to the code, there is a pound sign at the beginning, meaning this is a comment. I put that there because I don't want to install the package every time I open R. The package, you install it once,
Okay.
okay? And you don't have to install it ever again unless you want to update RStudio. And you will, but not yet, because you just install it. So this package, you only install it once. You need internet connection for that. But yeah, usually we have it. And the things that we have been doing so far, the functions we've used, for example, mean, structure, summary, we've been using those without installing any package because R has some basic functions already installed. So that's what is called base R, and we've been using those without installing any package because it's already embedded. So what is a library? A library, it's the command that is going to give you access to those tools that you have already downloaded. So you bought those tools, you have them with you already when you install the package, but to be able to use them, you need to run the library. You need to call the library. And you need to call the library every time you open R. Okay, so usually what I do, I put all my libraries, all the libraries I'm using, at the beginning of my R code, of my script, and I run them at the beginning and just forget about them. If you don't run the library and you try to use a function, a tool, within that library, it's going to tell you, I don't know which function this is, because you didn't bring that box of tools. So you don't know, you cannot pick that tool because you don't have it in front of you. Okay? So we're going to be working with Tidyverse. Tidyverse, when you install it, it's actually installing around like 20 different packages. So Tidyverse is like a package of packages. And these are, this is a summary that I found online. I think it covers everything that is out there so far. You have some packages to import data, to explore, and to communicate. The ones we're going to be using are going to be dplyr and ggplot. There is one that I discovered recently that is Haven that can read SAS files. So that can be really nice for you, I think. I haven't explored it, but we will be able to explore it one by one if you want. So Tidyverse has some motto or slogan, and is that they are working with tidy data. Each column is a variable, each row is an observation, and each cell is a value. I think for us this is what we are always working on with, so it's not difficult to understand. The good thing is like it takes one step at a time and connects simple steps through pipes. You will see what a pipe is. It's really easy to read and it's easy to write once you understand how it works. We have been working so far with data frames, but now they call it table. And a table is very similar to a data frame, and actually it is a data frame, but it has many other characteristics. We're going to see some of them. So if you go to R, you are in No Solution, dplyr. You're all here, are you? Yeah, okay. Tidyverse, if you are lost, just come here. Chunk 2, Tidyverse. You already installed the package. Now, you see, I just open R. I didn't install it because I installed it the other day. I hope, yeah, because this is using my computer. So now I'm going to call the library. Okay. And it seems that it's telling me a lot of things that I don't know what they are. Let's go over them a little bit. Attaching package, it says, okay, I'm attaching these packages. These are not the 20 packages I told you about. So what you're doing when you're loading the library Tidyverse, you are uploading 8 different packages. Okay, not the 20 of them, because usually you don't use the 20. You use some of them. These are the core packages that you just installed. It's telling me that it has some conflicts. Okay, I don't know if for you it's the same, because I don't know if you have the same packages as me. Yeah, okay. So what it's saying is like, we have conflicts with the function filter. Okay, there are 2 packages that have the function filter. One package is dplyr, and the other package is stats. So the function filter from dplyr is masking the function filter from stats. Okay? So if I write down my code and I want to use the function filter, by default it's going to use the function filter from dplyr. Okay? But what happens if you want to use the function filter from stats? So you can just call it, you just have to write out the name of the package and then write these two colons. Thank you. Okay? And that will say use the function filter, but use the one that is from the package stats. Okay? So I will write it down here. Stats, filter, and then I do whatever. Okay? So one of the things that Tidyverse has is that a lot of their functions, instead of being the words separated by a dot, they are separated by an underscore. Okay, so now you have to be careful how you call your objects, the new objects you are creating. Just remember that Tidyverse is usually using underscore. This function here, it's a little bit different than the one we used last time. Last time we used read.csv. And then we put this here. By the way, sorry. Do you know which working directory you are on? Because now we are going to be loading data. So we need to tell R where we are. To get the working directory, we say get working directory. And mine says, okay, you are here. I'm fine. Are you okay?
Just a question.
Yeah.
So the two dplyr from last week is the same from today? Because I noticed there were some modified.
Yeah, no, the folder, the folder is the same, so the location is the same. You're gonna have it.
Because I'm using from last week. Do we need to? Did you make
The-
updates today?
Yeah, I made updates to this file. So the one that we had last week is called a little bit different, and it's called first two chunks. So the one we are using today is dplyr no solution. Okay?
So if I'm not in the G directory, I'm in C users L Palmer, is that a problem? Should I be?
It's not a problem as long as you copy these files. So you're gonna need this file, copy these
Yeah.
3, these 6. You're gonna need these 6 files. I mean, you can copy the whole folder if you want. And then, yeah, I think if you were not here last week, you can go a little bit higher in the code, okay, at the beginning.
And I didn't have a chance to work through it. Okay, so I have to run that too?
You need to write this one, but yours is going to be a little bit different, okay?
Okay.
So if you, well, I can go with you for when we have the first exercise, I'll
Okay.
come back to you, okay?
Okay.
And then we can look at that together. So now we are going to be opening, so if you know your working directory, you need to be in your working directory where you have these files. Anyone who has a problem, let me know and I will come back for you. Everyone's fine? Okay, so if you run this line here, read_CSV, you're going to get this huge thing. If you have a problem, just use the red sticker and I will know you have a problem. Okay, so here you see that the line ran. Okay, we have here in the environment uploaded that data, so it exists, perfect. You can open it and look at all the different variables we have there. So what is this telling us? What Tidyverse is saying is like explaining to us a little bit what's happening, and it says, okay, we have all these columns in your data set, and it's interpreting this record ID as a number, this month as a number. Remember that double, integer, or numeric, they are going to be numbers to us. R has different ways of naming them, but to us they are just numbers. This one here, species ID, is a character. Okay? So if you now run structure surveys, you're going to see that species ID is a character. Okay? So what Tidyverse is doing here is, like, as soon as you load the data, it's already telling you what type of data those columns are. You don't even have to ask it, okay? If you want to change the type of data it is, for example, I want to change this species ID from character to a factor, okay? Because a species ID is the ID of a species, the name of a species, so this is a categorical variable. So I don't want it as a string, I don't want it as a character, I want it as a factor. So the way we do it, I say it there, but I'm going to do it for you. So I take the same thing as I did before. Okay, let me make this. Is this big enough? Yeah. So we have the same thing that we ran before. I'm going to make a comma here, enter, and then let's look for that. I write this, call types equal, copy pasting. Okay, and what I'm going to put here inside is what R gave me when I first ran it. So this is the original line that I ran. So I'm going to copy all this. I paste it here. And now I'm going to say, okay, I want species ID instead of character, factor. Okay? Species, I don't want it a character, I want a factor. And then I just run it. So I have that here. This is what this is. Okay, and I made little comments so you know when I made the changes. This one I made it factor, this one I made it factor. And you can do this, yeah, however you want. Okay, but right now I'm going to run it like this. So when I run it like that, it doesn't bother me with that anymore because I just specify it. And now if I look at the structure of surveys, we're going to see that species ID is now a factor, okay? It says that here and it says that over here as well. Perfect. So now we have our data. We have loaded our data, and we have some of them are numbers, some of them are factors. That's what we want. What happens if I just call this data set? Okay, this is the output. You can see it's a little bit different. If you remember the one that we had with the data frame, it was way more simple, no? I'm going to go up there, and I'm going to run the one that we have. If you go to line 43, you're going to use read.csv. This is the file we loaded last week. Okay, it uploaded here, perfectly fine. What happens if I'm opening this? When we run survey, we got all these things. It's saying it is a table. These are the number of rows you have. These are the number of columns. This is the first column is a double, which is a number, blah, 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 factor. It's telling me which ones are NAs, okay? It's even marking them in red so you can see them easier. What will happen if I try to run like the same thing here, but with this one? This is a read.csv. This is the same file we had last time. This was a simple data frame. It was not a table. What would happen if I just run that? You want to try? Wow, huge, no? I ran it, and it's trying to return the whole data frame. It's very long, so at the end, RC is saying, okay, I reached my maximum. There are still almost 35,000 rows that I'm not printing. So, okay, thank you, R. I don't want those many printed here. So that's one difference here between tables and data frame. If I call a table, it's only going to print the first 10 by default. If you want more, you can always say print surveys and give me 15 rows. So it's going to give me the first 15 rows. Okay? This is a bit more helpful than just a data frame running, because as you saw, if you just type the name of your data frame, it's going to give you like 10,000 rows. That's like a lot. We don't want that. I'm going to minimize that like a little bit and go back to where we were. Okay, so that was already one difference that you saw. If you run head of both of them, this is what you're gonna find, okay? Head, remember, is a function, then it's gonna return the first 6 rows. This is service base, the normal data frame, and this is the table. Okay, so you can see the differences. Here we have nothing, here we have the NAs, okay? Here is specifying what type of vector we have for each of those columns, okay? If we run structure of both of them, this is the structure of the data frame. We already know this function. Now we run it with table. It gives you some extra information, as we saw a little bit before. If I run class for both of them, this one is a data frame, and this one here is 4 different things, okay? It's different, like table type of data. It's a table, and you can use it in different ways. That's what you need to care about right now, okay? But as you see, it is also a data frame. So it's like a chameleon. It can be different things. As we already saw, we already saw some of it. We have 2 main differences between a data frame and a table. One is the printing. This one we already saw, okay? So if we run the name of a table, it will only give us the first 10 rows. If we do the same with the surveys base, with the data frame, it's going to try to give us plenty. We don't want that, so that's one of the differences. Another difference about printing is like, if I print the first, let's say I print the first 15 ones, we have it here. It gives me all the columns here. But if I do the same thing, imagine that my window is way smaller, like this. And I run the same command, okay? This is the same one that I just ran. It's only giving me the first few columns, and then down here, it's saying there are many more rows, okay? And there are also 5 more variables, and these are the variables. You're missing those variables. You cannot see them here. I don't like that. I want to see those variables. So to be able to see those variables in a small square like this one, you say the width of my table is going to be infinite. And this means give me all the columns that I have. So give me the 15 rows of all the columns that I have. So if I run this code here, it's going to give me all the columns. And when it finishes here, it cannot print more. So it's just going to print it down there. Okay? That won't happen. You won't see any difference if you have this open big like this. But if you're working in your small screen in your laptop, you will have that problem. So I wanted to mention it. Okay, the other 2 big difference is indexing or subsetting, okay? With base R, we were using a lot of the square brackets and the $sign, okay? That's fine. The problem with that is like in base R, square brackets sometimes returns a data frame and sometimes returns a vector. A vector is just one line. A data frame is like you have rows and columns. It is a problem when you are using one function, which is this one, and you are getting 2 types of results. If you are trying to code something, like do some automation, and the output of your call is different, sometimes it's a vector, sometimes it's a data frame, you're going to run into trouble later on. Okay? Either you're going to have to write code for the output if it is a vector and for the output if it is a data frame, or you're going to have to run into problems. So the good thing with tables is like the square brackets always return another table. Okay? This might not have, it may seem that it doesn't have a lot of importance right now, but if you're working more with this, you will have, this will be very useful to know. So for example, when we're using surveys, we're using a table. When we are using service base, we're using a data frame. These 2 lines are exactly the same as these 2. I'm just changing the data that I'm using, okay? This is a table, this is a data frame. If I run this one, it returns a table, okay? If I run this one here, it returns a table, perfect. However, this one here, what I'm doing, I'm saying give me all the rows of the column month of this data frame, okay, same as here. If I run it, it's giving me a vector. It's saying this is an integer vector, okay? If I run the thing that it's inside, this is the vector that it's giving me, okay? Whereas this one here, is a table. Okay? If I do the same with the second line here, it's going to return a data frame. Okay? If I run the thing that it's inside, what am I doing here? I am saying, give me all the rows, so this is going to be long, but give me only the columns month and day. So it's returning a data frame with 2 columns. Okay? You will see that there. Okay? So this is going to be important when you're coding a little bit like more things. Tables are good because they always return the same object when you are using square brackets. Data frames, they can return a vector or a data frame, depending on what you're giving them as an input. Okay. Now, if you encounter, if you find a function that doesn't work with tables, because that can happen, for example, the social network that we're going to be using wants data frames, but some of the functions we'll see. You just have to do, okay, I have this is my table, but I'm going to make it as data frame. So I could write that surveys data frame. So if I create this object, what we are doing, so let's see again. This is a table, okay? And now I'm assigning this, which is that table but transform it into a data frame, to surveys data frame. So I run that one, and now I say, okay, what is the class of surveys data frame? So what do you expect to see?
Data frame.
Data frame. Okay? So this is very useful. You might have to use it. If it's the other way around and you want to convert a data frame into a table, you do the same, but you write as the underscore table. Okay? So that's the introduction for Tidyverse. Any questions so far? Okay. So today we're going to be learning these functions and a couple others, but the other two I'm not going to spend time of them unless you really want to. I created the documentation, but I want to explain them. So these are the functions we're going to be using. These are the tools we're going to be using. We're going to use select to choose columns. We're going to use filter to choose rows. The pipe operator is this one. It's going to help us link different functions together. For example, choose a column and then choose a specific row only from that column. Okay? We're going to have mutate to create new columns inside our data frame. We're going to have group by and summarize to and count actually to kind of create frequency tables. Okay? So let's go to chunk 3. And yeah, we're going to have our first exercise really soon. Using the function select and filter, we mentioned select is like you are selecting from your your table. Okay, when I'm speaking, I'm still going to say data frame because I'm used to that. But imagine every time I say data frame from now on, it's just table. Okay, so we have our data frame surveys, and we are going to select the columns, plot ID, species ID, and weight. If you don't remember the names of your columns, you can always say names, surveys. It's like, okay, tell me the names of the columns of my survey data frame. And it gives them to you here. Okay? Tidyverse and, well, Tidy and dplyr, they, I think almost usually always, starts with the name of the function and then the name of your data frame. Okay? Then you put a comma and then you do whatever you want to do. So if I run this one here, select surveys, these 3 is going to return a data frame or a table with only those 3 columns. Okay? If I run this second line, it's going to select from that data frame or table all the columns except these 2. You can run it. If you want to keep one and remove the other one, you can do so. Well, actually this one, yeah. This is equivalent of not saying this one. Okay? For filter, we are filtering by row. So I'm going to call the whole data frame here so you have it. Okay, this is what we have. And I say, okay, I'm only interested on those observations that were collected on the year 1995. And I say filter my data frame surveys by year equal 1995. Okay? This is the same thing as what we saw last time with base R, but in base R we had to do something like this. Okay? So if you remember here we're saying, okay, surveys column year equal 95. Which position? So tell me the position of my data frame surveys where year is 1995. And then here with the square brackets, I say, okay, give me those positions, plug them into the row, and then give me all the columns from the data frame survey. The output is the same, okay? But what do you prefer, base R, which I think is a bit complicated, or dplyr, which to me I think is way easier to understand. So this is one of the powerful things of using dplyr. When you see this code, it's way easier to understand and to write than this one here. So there are some exercises here. I want you to do them now, okay? Okay, so we're going to show the solutions. I open here the full one. You also have access to it, but just don't open it until you finish it today. So the first one is like read this other file, okay, CSV, using the Tidyverse functions read underscore CSV, okay? So we read it, we create this new object that is called nodes. This is the one that I showed to you in the PowerPoint actually. And then I say subset by premise type, okay, and choose, farm. So here we're saying filter, so I'm referring to the rows with filter. Filter the data frame or table nodes, and in the column premise type, give me the ones that are farm only, okay? So it is here. One thing that Sam pointed out that it's very, very important is that right now we are just displaying it, okay? We are not creating any new data frame that we are going to keep. Why not? Because we haven't created an object. We haven't assigned this value to anything. If we want to assign it to something, we can say, I don't know, nodes, farms, and then assign. If we do this, I'm going to create a new object that is called nodes farm, and it's going to appear here. Okay, and we have it in there. I'm not doing this right now because we're going to be doing a lot of exercises, so I don't want to have like 20,000 different data frames. But when you're actually working with it, you should need to assign it to an object to be able to work with it, because now we just displayed it. That's it. It's anywhere else except here, and this, because it's in the console, it's going to disappear. So then I say, give me the first row of what you just did. So remember the function head. If I don't say anything, head will give me the first row. There are many ways of doing this. This is only one of them, okay? Then I say subset, choosing only the geo coordinates, okay? So that is latitude and longitude. So select from the nodes data frame latitude and longitude columns. So I do that, and this is the beginning. This is latitude and longitude. Perfect. Give me the first 18 ones, and you can do head, or you can also do print, okay? Different ways of doing the same thing. Then I say, do you have this? You don't have the results, no? I deleted it. Let me see. Okay, yeah. So this is a different way. These are different ways of doing both of them at the same time. And maybe each of you have done a different thing. You can do what we call intermediate step, which is I first filter and create a new data frame for that filter data frame. And then once I have this one, I plug it in here and I select latitude and longitude. Okay, this is a way to do it, although there is a better way. A different way would be what we call nested function, which is we have select. Inside select, we do the filter one, okay? So this means we first filter, and then from this data frame, I'm going to select these two columns. Okay, this is okay, but it can be messy and very complicated if you want to do a lot of things at the same time. So there is a better way. We're gonna see just after this. Just one little thing. Did you notice that we are missing decimal points here? Latitude and longitude usually have like many decimal points because it's a location. So if we say this, maybe it's like, I don't know, the whole California. This could be the whole California. Actually, this is from Thailand, so it's not California. But so that is only for the display. Okay, if you do, let's see here, I created this data frame premise style. Let me look at it. Okay, here we have them. If I want to see the full values, I can do view and then the name of my data frame. And you will see that the decimal points are still there. They are stored there. They didn't disappear. It's just that because there are many decimal points, dplyr decided to show only a few of them. This is a characteristic of dplyr that I don't like personally, but it's okay. I can live with that. If you really cannot live with that and you want to see all the decimal points, when you're printing your data, you can say print data frame. Okay, and the output that is going to give you is going to have all the decimal points. So here I'm just doing, select from nodes latitude and longitude, but just give me the first 6. I don't want to have like 10,000 rows printed. And then I say print data frame of that. So if I run this, it's going to give me, it's going to show me all the decimal points. Okay. Pipes. Pipes are these little things here. Okay, that is what we call a pipe, and we read it as then. We're going to see an example. This is very useful when we want to do more than one thing at the same time. We run one after the other. For example, the same example we just saw right now about filtering and selecting at the same time. We saw the intermediate section way of doing it. Okay, you create a new object and then you use it. Perfect. You can run this code. Okay. It takes 2-3 lines of code. It's okay that you are creating intermediate objects, which can be annoying. You also have the nested function that we just saw as well. Okay. We can run it. It's okay as well, but again, it can be very messy. So, by the way, what are we doing here?
I'm thinking out loud.
Okay.
To get only weight less than 5.
Okay, filtering to get weights only under 5.
And only selecting species, sex, and weight.
Perfect. Perfect. So once we have this data frame that has weights only lower than 5, we're going to select only these 3 columns. Perfect. So that's what we are getting, and that's what we're asking for. That's what we are getting. That can get really messy. So what we are going to be using from now on is what we call a pipe. A pipe is this sign here, and you can get it in Windows with Control, Shift, and M. That's a shortcut to get it. We read it as then. So for example, these 3 lines of code here say, take the data frame surveys, and then filter by weights that are less than 5. Filter, remember, is for rows. Once we have that, then we are going to select the columns species ID, sex, and weight. Okay? So if you look at this, this is way more easy to read than any of these two. We are not created intermediate objects that is going to build, take all this space and take names that we might want to use later on. We are not creating nested functions, which can be really messy. We have a big thing that, like a big order that we are giving to R, and it's really easy to read. Take surveys, then filter, doing this, and select these columns. Okay? You can also add another command here. Once we do all this, I say, okay, then print the first 10. Okay? So with that in mind, please do the next exercises and stop here in a range. Okay, so you have 2 exercises to do. Perfect. So we have the results somewhere here. Okay, so for the first one, I say filter by year, everything that is younger than 1995, before 1995. So take the data frame surveys, then filter by everything that is before 1995, and then select the columns year, sex, and weight. Okay? If you run this, you will get what I was looking for. For the second exercise, I'm talking about the data frame nodes. And here what we did is like take nodes, then filter by all those that are premises type farm, and then select latitude and longitude. This is what we did before, but now we are doing it with a pipe. Okay? And again, if you want to see all those decimal points, you can just put everything that we wrote down here in parentheses, and you put it inside the function called print data frame. So if I run this, Control Enter, that's what you will get. Okay? Any questions? Now for arrange. Arrange is another of these nice functions, and what it does is like it rearranges the result of a query, something that we're asking for. For example, if I say arrange the data frame surveys by weight, it's going to do it in increasing order if we don't say anything. So it's basically ordering the whole data frame according to weight, which is here, and it's giving me the lighter ones before. So it ordered by weight and it's providing me with the lighter ones. If I want weight to be ordered in decreasing order, we say descending. Okay? Arrange surveys by weight, but do it in a descending order. So now we are going to get those birds that are heavier at the beginning. Okay? Missing values are always, when you are arranging, they are always put back at the end of your data frame. So if you remember, there is a function that allows you to explore the 6 last rows of the data frame, and that is tail. So tail is similar to head, but instead of starting at the beginning, it starts at the end. So if we look at this at the end of this thing, we're going to see that there's plenty of NAs in the variable weight. Okay, so this is good to know when you're arranging by something and you have NAs. The NAs are going to be pulled back at the tail of the data frame because it doesn't know how to arrange those. Okay, the same if you are doing the descending, you're going to have all those NAs there. So we have some exercises here. If you want to do it, 3.3. Yeah, it's only one. I'm sorry for that. I want to make you think, and yeah.
No, you think you get to check other code you've written to see what.
Yeah, exactly. Exactly. That's the way to go. That's how I learn R, looking at different codes that other people wrote and go from there. So I asked you for a lot of things. There are different ways of doing it. I put here 2, but maybe there's another way of doing it as well. So what I'm doing here is take the data frame surveys and then filter, okay? And we wanted to filter by, we wanted to get only all the values that are lower than the mean. But if you remember, and that's my second tip, when you're using mean of a vector that has NA values, you need to say, okay, remove the NA values for the calculation of the mean. Okay, otherwise it's gonna give you some problems and you won't be able to run it. So take surveys, then filter and choose all the values of weight that are lower than the mean, then arrange by weight, then select these 3 columns, and then print the first 13 observations. If I run that, it's giving me what I want. Okay? It's giving me the first 13, the 3 columns that I wanted, and it's showing the first few rows are the lower weight. Okay? You could also change the order of this array and filter and select. In this case, you cannot always do it, so you have to be very careful with the order you are asking R to do things. Sometimes the order doesn't matter much, but sometimes you are gonna get something as an output that it's not what you want. So remember to read all the time and take in the data frame and then do this and then do that. Okay, the order is important. In this case, we have 2 different ways of doing it, but if you keep messing around with those lines, you're not going to get the output you want. Another function we have is mutate. Mutate creates a new column of your data frame with the data that you have in your data frame. For example, here, what I'm doing is like I take the data frame surveys, and then I'm going to create 2 variables. When you open mutate here, the first argument that you're putting here is the name of your new variable. So here I'm creating a variable that is going to be the weight in kilograms instead of grams, because so far the weight that we have, these are little birds, it was in grams. So I say, okay, create a new variable that is going to be called weight kilograms, and that is going to be weight divided by 1,000. And that's going to give me, it's going to transform from grams to grams. And then, this is a comma, I'm going to create another variable that is going to be weight kilograms squared. And for that I'm going to take this new variable here, square it, multiply by 2. This is multiply. I'm going to multiply, so this is, I will modify this in the code that I'm leaving at the end, but if you're not changing the file, please modify this now in your code, if it's in your folder, because like that, when you go back to it, if you want to square in R, we use
2 asterisks, don't you?
we use the little hat sign,
Oh, you said.
which I don't find in this American keyboard here. So if you see in the console, so if I say 3 square, this is going to give me 9, okay? If I do 3 star 2, it's going to give me 6. Okay, this is R. So what I'm doing here is like I'm creating a new variable that is 2 times the weight in kilograms. And for me, this is amazing, because I'm asking R to do an operation with a variable that I have not created yet. So in the same command, it's going to create this new variable and use it. I find it really clean, because you don't have to do different steps, different chunks of code. You can do everything at once. Okay, but again, very important, the order. If I put this one before this line here, before this one, it's not going to know what's happening, because it still doesn't know what weight kilogram is. Okay, and then I'm saying give me the first 6 rows. I run it and I get what I wanted. This other example here is the same thing, but I can use print and then I can actually specify a different number. Okay, for example, if we want to do this thing, we want to save the problem that we had before with the NAs. And I want to create this data frame that I'm creating here. It still has NAs. I want to create one without NAs. So remember, we can add another line, okay? And we can use the operator that is this exclamation point, that is no. So filter the data frame surveys. So, sorry, first, take the data frame survey and then filter and give me everything that is not an NA in the variable weight. Then create this new variable that is called weight kilograms, and then show me the first 6. Okay? If you compare those two that we ran, here in the data frame weight I have plenty of NAs, but this one here doesn't have any NA. Okay? So now it's time for you to do an exercise. Do 3.4 and 3.1. Okay? 3.41, sorry, and 3.42. I want you to do those two. And 3.42, you have the solution, so please delete it. Should not be there. Don't look at it.
Because the
Okay, so I pull out the answer here. There are several ways of doing it, and this is one of them. I created this name and I call it surveys hindfoot have 1 because I'm going to show you a couple of options. Then I say assign, okay, whatever I'm going to do here in the right side. So take surveys and then create a new column that is going to be called like this, and what I want inside of that column is half of hindfoot length. Okay, once you create that column, then you're going to filter and you're going to remove all the NAs. Then I want you to remove everything that is higher than 30, or just keep those that are less than 30, and then select the columns species ID and hindfoot half. If I run this, I'm not getting anything, okay, because I created this object. So I'm just going to call it, okay, and here it is. This is the baby. Okay, there are different ways. I have this other one, number 2. So you have survey, and then I filter and I remove the NAs, then I mutate, and then I filter, and then I select. Okay, would this be the same as what I did? I'm not sure, but I'm going to compare. Okay, I just ran it. So I created this object and I have it somewhere here. And now I'm going to do a summary. I'm just double checking here. I want to see if this one is the same, so 2 equal signs, than this one. And everything, both columns, say true. Yes, they are the same. If they were not the same, it would tell me something else. And I did something to see that here. I created another one. This is number 3. And here I'm filtering. I'm removing NAs first. Then I'm removing everything that is above 30. I'm keeping the ones that are below 30. Then I create my new variable, and then I select. If I do this one, and I compare it with the first one, for example, it's giving me this error. And it says, I can only use this argument, these 2 equal signs, when the 2 data frames I'm comparing are equally sized. So this is already telling me they are not the same, man. Something happened there. And you can look at the dimensions because, okay, equally sized data frames, they probably have different dimensions then. That's the size of a data frame. We see that the third one has this many rows and 2 columns. And the first one and the second one, among themselves, they are exactly the same, but they are different than this one, okay? So as you see, sometimes the order does not matter, like here, but sometimes the order matters. So be sure that you are calling the arguments with the order that you want. We're going to start the class here. Okay, you have another exercise and a few more things that if you want, what we can do, we can work on that on Wednesday, but you can work on that on your own. So what we're going to do on Wednesday, you're going to have all the documentation, everything we didn't finish today, okay? Plus those 2 little functions that I already told you at the beginning. I don't want to go over them because I don't think you're going to be using it, but it's there in case you need to use it. On Wednesday, we're going to have time for you to work on your data frame, your data. So bring your own data, okay? You are gonna have to use it in a CSV format, so be sure you have it in a CSV. Be sure you have it in one of your folders. You're gonna open R, you're gonna load your data, you're gonna explore your data, and then you're gonna do whatever you want with it. You're gonna clean it, you're gonna manipulate your data frame. You can, if you are thinking of a social network, you can try to start creating those two data frames we have, the edges and the nodes data frame. But if you're not working with a network, it's also fine. I just want you to practice these commands that we are learning with your own data, so it will be more meaningful for you. So what we can do on Wednesday, I'm going to be here. I'm not going to present anything. You're going to have this code. So if you want to work on this code, you can also work on this code. If you want to work on your data frame, hopefully, you will work on your own data. And I'll be around and I can walk, answer questions, and maybe if you want to think, I was talking with Moniz earlier. She said, my data is clean already, but I want to do these things. How do I do it? And we can do all those things together here on Wednesday. Okay, so I'll go one by one. If you don't have ideas with your data, we can come up with something together. But if you have an idea, that will be great. And then if you cannot do it on your own, I will help you. Okay, so that's what we're going to do on Wednesday. Is that okay?
Sure.
Yeah? Perfect. So thank you.
Thank you. Thank you.